In this demonstration, we'll look at some SQL functions and aggregations. For all of these examples, we'll be using this ER diagram that's on the screen with these four tables, and you can see the relationship and keys between those four tables. Our first example, we want to get product name, price, and discounted price. So product name and price are both coming from the product table, although discounted price is not here. And discounted price I want to show as 20% off of the normal price. That's not a field we're going to find anywhere inside of our ER diagram, therefore it's something that we need to create. And we're going to use a calculated field to get that. So let's start with what we already know. We're going to select the product name, that's already in our ER diagram, and we're also going to get the price. And let's give this an alias of normal price, because this is the price before any discounts. I need to have this surrounded inside of double quotes because I have a space in here. If I wanted this field to simply be normal price, it is not required that I put this inside of double quotes, but I would like that space in there, so I need those double quotes. And then my next field is going to be my calculated field. So how am I going to calculate 20% off of the normal price? Well, that's going to be price multiplied by 0.8, or 80% of my normal price. And let's give this an alias as well. So those are the three columns that are going to appear in my query results. And where is this coming from? This is coming from the product table. And we're not specifying any criteria, nothing in the where clause here. So now if I run this query, I apologize, product name with a T. There we go. So here are all of my normal prices and discounted prices. If I had a calculator, I would see that $70.39 is 20% off of this price. And notice that I'm seeing 3 decimal places here. That's not something we want to see for prices. So let's clean that up a bit by rounding this. Let's round price times 0.8 to the nearest 2 decimal places. That's what this round function is going to do. And now when I run this, that discounted price column will look a lot cleaner here. So $18.99, 20% off of that would be a price of $15.19. Okay, that looks good. Let's go on to our second example. And so in here, I want the sale date, customer ID, and sale price for orders placed on or before December 31st, 2014, and I want to round my sale price to the nearest dollar. So we're going to use that round function again here. So what do we know? We know our sale date and customer ID. And then sale price, except we need to do something with sale price. We need to round sale price. So I use my round function, which is in all caps because it's a reserved SQL keyword. And I want to round this to the nearest dollar, so I want to see 0 pennies in there. And so to 0 decimal places. And where is this coming from? This is coming from my sale table. And here I do need a where clause because I'm just looking for sales that happened on or before December 31st, 2014. So where the sale date is less than or equal to, we can use those greater than, less than, greater than or equal to, less than or equal to operators with dates as well. So less than symbol means before when we're working with dates. And I need to specify my date keyword and then my date in YYYYMMDD format looks like that. So now when I run this query, you're going to see all of those prices are shown without any decimal places. One thing I want to clean up here is that if you don't specify a alias for a particular column, you're just going to get the entire expression, which that's an ugly expression. We don't want to see that in our query results. So let's give this an alias of perhaps rounded price. And now that third column will look a little better. There we go, rounded price. Here's my third example. I'm looking for all customer fields for customers that live on Main Street. Okay, So we want all customer fields, so that's going to be an asterisk here, and that's coming from the customer table. Now here's where, without using any SQL functions, how could we specify that the customer lives on Main Street? Well, we can't just do where street address equals Main Street. We can't do that because in our ER diagram, street address here is going to contain both a number. We're going to have 1, 2, 3 main streets. We might have 1, 2, 3 Main Street apartment B. So there could be some other text before or after that phrase Main Street. And nobody's address is just simply going to be Main Street. Therefore, I need to use our like keyword. So where the street address is like, and then inside of single quotes, I need an expression here. And that expression is going to use wildcards. So in SQL, the percentage sign is a wildcard that means 0 or more characters. And those could be any characters. They could be spaces, they could be letters, they could be numbers, and there could be any number of them. So anything, and then the phrase Main Street, and then anything. That's why we have a percentage sign both before Main Street and after Main Street. So now if I run this query, I'm going to see street addresses. All of those have Main Street in there at some point. They could be in the middle. Here's one that has both text before and after Main Street. All of these results here have the phrase Main Street in it. And so this is an example where we will use the like keyword. Let's look at example 4 here. So now I'm looking for first and last names of customers with 4-letter first names that start with J. Kind of a crazy query, but it teaches us something. That's why we're doing this crazy query. So we're looking for first name, and we're looking for last name. Those are the 2 fields we want, and the only 2 fields we want. We want this from our customer table. And then where, we're going to have to use like again, because there's no way just using a where statement we can get a 4-letter first name that starts with J. But if we do where the first name is like, and then have another expression inside of these single quotes here, well, we know that it should start with J. So I don't want any wildcard before the letter J. And then I don't want to do this, because this could be a 2-letter name that starts with J. This could be a 20-letter name that starts with J. I specified a 4-letter first name. Therefore, I'm going to put in 3 underscores, 1, 2, 3. And I'm sorry those aren't showing up, but those are in fact underscores that I've typed here, 1, 2, 3 of them. And those underscores work like the percentage sign wildcard, except that they specify only 1 character. So the letter J followed by any single character, another single character, and another single character. And now when I run this, I should see a lot of first names that are 4 letters long and start with the letter J. Every single one of those. If I wanted 5-letter first names, I'm going to add an underscore in here. Now let's look at some 5-letter first names that start with J. Or if I wanted 5-letter first names that started with W. There we go. So that's the difference between the underscore and the percentage sign. I'm going to put a percentage sign back here so you can see what happens. W percentage sign is going to be any first name with any length that starts with the letter W. And if I did percentage sign W, this is going to be any name that ends with a W. And this is case sensitive, so let me change that to a lowercase w. And so all of these names now are names of any length that end with a W. Okay. Our next few examples are going to use SQL aggregation. So the date of the first ever order placed. So in here, this data is going to come from the sale table. And I want to select the min of the sale date. When we're working with numbers, min is going to be the lowest number. When we're working with dates, it's going to be the earliest date. So the earliest date in our sale date field in the date table is what this is going to return. And let's give this an alias of first sale. And this is coming from the sale table, and that's all I need. Now all I'm going to get in here is one single query result. Does that mean that the sale table only has one record in it? No. But whenever you are doing these aggregate functions, we are just going to get one value. And there it is. Our first sale occurred on December 31st of 2013. Let's look at another aggregation. Or not an aggregation this time. This is another function. We're looking for customer full name. Let me just show you what the customer table looks like. So right now there is a separate field for both first name and last name, and I want to see just one field that shows first name, last name in a single column here instead of two separate columns. So I can do that with this function called concat. Concat is short for concatenate, and every programming language has a way of turning two strings into one string with some sort of concatenation function. And the arguments we're going to pass this concatenation function is first name and last name. And let's give this an alias. And now let's see what this does. We're just going to get one single column, and in this column we're going to have first name followed by last name, which is getting the job done, but you might notice there's no space in there, and so it looks a little ugly. And unfortunately, with the concatenation function in Oracle, we cannot have multiple arguments. I would need to nest multiple concatenation functions inside of each other to add a space between the two. So usually, when you want to put a space between two fields, you use, instead of the concat function, you use these double pipes. And the double pipes are another way of concatenating. So what am I doing here? I'm saying first name and then attach to that string a single space, and then attach to that the last name. So now we are going to in fact get that space in between first name and last name, and that's looking a lot cleaner. Okay, back to aggregation. In this example, I'm looking for the price of the cheapest product. So we used min before with respect to a date, and now let's use it with respect to a numeric field, which is price. So the minimum value in the price field, and let's give this an alias of cheapest product or cheapest price. And this is coming from the product table. And that's all we need here. Our cheapest product that we sell is $6.99. What's the most expensive? I can use my max function here. The maximum price is going to be $180. What is the average price? We can use the AVG price, and that's again just going to give us one result here, and that's going to be the average product price. Another function we use is sum. This works like sum does in Excel. It's going to add all of the values that are in the price field in the entire product table. And so we get a big number there. We get a number over 68,000. Our final example, let's look at the item size of the largest shoes that we sold. Item size is a numeric field inside of our sale table. And so this time we want to select the max of item size and give this an alias of largest shoes. And this is coming from the sale table. So run this query. What's our largest pair of shoes that we sell? 12.5 is the size of the largest shoe that we sell.